Today we continue with our session. Yesterday we stopped at where we are talking about performing one hot encoding, where we talk about saying given your data set, you may have categorical data, right? We can have categorical data, something like this: color, green, size. We have green, red, ML. And this is continuous value. And this class level, we said for you to do machine learning, you need to change all these categorical values to numerical value like this, because machine learning do stuff better than this. So what we said, okay, now how can we convert this? We talk about the first one, which is mapping features. So for example, we can see here MLX. This is what we call ordinal features. That is, XL is greater than large and large. So in this case, we can do what we call mapping, which we discussed yesterday. So we can create a mapping like SL is number 3, L is 2, M is 1. And now we can map these values here. We can see the size. We give SL is 3, this. So this is for ordinal features that they have some kind of order, right? But these features like green, red, blue, they are not ordinal features, right? They are basically just nominal features, that meaning that they don't have any order. Just excuse me 1 minute. So we can see that this categorical green, red, blue, they are not ordinal, they are nominal. So we cannot give them such kind of order. So we said we can give them anything. So, but we say that, okay, what about our class level, the target? So if you have class level also, you can basically, because class level are also not ordinal, we can use something that is provided with scikit-learn. You can also use the idea of mapping to map these to this, but you can use scikit-learn class, which is we call Sklearn encoder. We can call this encoder. We can see here that we can use level encoder. We import level encoder here, and for this we level encoder where level encoder, and we can see here we import level encoder, and now we create an object, and now we fit transform the class level. We can see the class level, the value. So you can see here we have the classes, class 2, which are 1 and 1, and class 1 is given 0. So we use this level encoder. We can see from level, that is your categories, they are called level. So you can use this to transform that, and this is the bus. So performing one hot encoding on nominal features. So we can see that we perform, given our data set here, because these are ordinal features, we can use mapping, right? But these are nominal features. How can you deal with nominal features, those that are ordinal? So one solution, we said we use what we call one hot encoding, right? So what is one hot encoding? Given these green, red, blue, we can basically still give them like values 1, 2, 0, like just give. But the issue here is that we can represent this green, red, blue with values 1, 2, 0. But the issue is the machine learning models will think that there is an order between green, red, blue here. So it will not works well. The solution is what we call one hot encoding. So because red, blue is this, we can see our red, blue, green. So we have 3 different colors, right? So we have red, blue, green, right? So you can see because the column name is called color. So here we can see it names them color. Then it attached with the variable color red. This is what scikit-learn also is doing. You can see color blue, color green. So we have color. So what this is telling us here, for the first row where we have red, we can see that yes, we have red because this is red and all other will be 0. For the second row, we have blue. So where is blue? This is blue. We have 1. All others will be 0. For the third one, we have green. So where is green, 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 green? Here, all others will be. So this is what we call one hot encoding. So this will now represent these colors, one hot encoding. So this is it. Now, how can we represent that? How can we do that with with scikit-learn, we use what is called one hot encoder. So you can see here, we imported one hot encoder, and now these are the class levels, our headers for our data set. And now we input, we can see here, we take the first column, which is this. If we look at this first column, green, red, we take the first column. We can see here, we create an object, one hot encoder, and now we fit transform on the first column. Can you see this is a first column? So we can see we get this, guys. So this is what we have. But also we can see that there are some situations whereby you have your data set, like you have nominal columns, like color and another column. You want to multiple operation on different columns. So we can use a new way, what is called column transformer. So a column transformer applies transformation to multiple arrays, to multiple columns. So you can see here, this is a data set. We say column transformer, one hot, if you look at this column transformer, how it works, if you go through something like this, yeah, you can see you provide the kind of operation you want to do. If you want to normalize, because you can use normalization, just transformation, any kind of transformation, you can use L1 transformation, any transformation. So column transformer, it just like it transform columns. It's not only here you can do what do you call it? You can do one hot encoding, any kind of transformation we can do with the column transformer. So here we can use, we said one hot, that is which function, one hot encoder, and now which column? The first column, that is this guy. And now do nothing. The algorithm is passed through, don't do anything to column 1 and 2. So column this and this don't do anything, right? So this is, we can see we transform this. But if we want to transform other columns, like maybe another column, like maybe let's say M size, this column, though is ordinal columns, is not nominal, but just for example, we can now say, okay, column 0 and 1, and don't do anything. So you can see, so this is what we saw yesterday. But another thing is there is another more inconvenient method to use pandas to do this transformation. So what we saw now is using basically scikit-learn, but you can use pandas as well to do this kind of transformation. Don't forget, what we are trying to do in this chapter is to transform our data set so that it is quite good and it is, perfect for machine learning algorithm to learn. So we can use also pandas. So pandas come with another functions called get dummies, convert categorical variable into dummy or indicator. So what we are talking about, these are called dummy variable because we don't have them, right? So this is dummy. So this is called dummy variable. So we can use this get dummy function from pandas. Remember, this where we use it is from scikit-learn. This is from scikit-learn. So, there are different ways to do different stuff. So anywhere ever you see something, just know that where it is coming from, right? So here we want to use pandas. You can specify the columns. We want to specify the column, price, color, size. This is our data set. So here we say get dummies. So here you can see we have blue, green, red, right? For our okay, so this is the data set, right? Remember here we don't take the class level, right? So we only take these 3 columns. So we pass this column, and this column, right? But get dummies know that this is numerical variable, so it will not affect anything. But the get dummies know that these and these guys, they are categorical variable. And they can, now you can see color blue, color green, color red. So for the first, these guys, and this one is size L, size M, size. So you get this one. So this is basically how you can transform your data. So you can see this data now as it is ready to be fit into machine learning model, because here you cannot fit in this data to machine learning model because you are categorical variable. Now here you can fit this data to machine learning model. Yeah, so you can see when we are using one hot encoding data, we have to keep in mind that this introduces multicoloniality. So there is some issue what we call multicoloniality, which I think we have not discussed it here. So multicoloniality is an issue where 2 features correlate with one another, like they make correlate, they don't actually add anything to the model. So in such situation, we can drop that. So for example, here we can see this one and this one. they are the same thing, right? They are the same thing. Can you see that? So 2 columns, they are the same thing. They add nothing to the model, right? So we can drop these ones. So if features are highly correlated, matrices are computationally difficult to embed, which can lead to numerically unstable estimates. So when you do estimate, it may not lead to good performance. So to reduce correlation among variables, we can simply remove one feature column from the hot encoder. So what is happening is that, okay, I can see that, oh, the one and this one, they are the same. I can just remove this one. So for you to do that, you can, when you use get dummies, you can just use the feature drop first. So this one, like you can see when we use this in this situation, drop first. So here we have the color green, color red, right? Size M, size L. So you can see here in each one, it dropped the first one. It dropped the color blue. Here it dropped the size L, I think, right? Size L. But here you are not losing any information because you can see like for green, for the color, when you have this, you have, someone may say when we drop the column for the color red, which one, color blue, someone may say that we miss some information, but we don't miss some information because, okay, when here you see 1, you mean you 0, definitely you see that this is color green, but here is 0, but here you see 1, definitely you know that the color is red, but here is 0, 0. Then definitely since 0 is 0, the other color is blue, must be blue. So you can see that when you drop a column, you don't miss this info. So this is what they are saying. I don't know if that makes sense. Please ask question if you have. Let's make it interactive. If you have question, ask so that we don't just move fast without good understanding. So that's how you drop columns in the get dummies in pandas, but you can also drop columns using one hot encoder. So remember here we use one hot encoder, right? So here we create the object one hot encoder, but here you can, for you to drop the first column in this case, you need to provide this argument drop first, just like what we do here in the pandas stuff. So when we say drop first, we create now an object called for one hot encoder, right? So now here we just provide the object we created, call a one hot encoder. Or like here, here we just call the object. You can see here we don't create any object one hot encoder, but we just call the function, right? It creates the object here automatically. But if you want to drop, you can create the object at first, and now you put the name of the object as we do here. We create the object and we drop this one hot encoder. Or you can even copy this one exactly in its entirety here, instead for using this, and now put it here and say, okay, this is this guy. Yeah, so but when you have this kind of lengthy stuff, it's better to create a variable to reduce this. So when you do this, it will also drop this one. You can see you have only 2 columns. So that is about creating converting categorical variable to numerical variables. Any questions? Ask question. Okay. It means ba a gane ba kenan inda ba a tambaya. Na gaji ana ta tambaya, it means ana ganewa. So
sir,
yes, go on, Falalu.
Yes, sometimes we use this pair plot to plot the pitches, because the pair plots disintegrate the pitches so that we can see whether there is there is highly correlated, whether the data is highly correlated
yes.
with one another.
Yes.
So how can we infer that from the graph? That's the problem.
Yeah. So here we have not come to that, which we will come to what we call dimensionality rejection and future extraction. In the couple of chapters, we'll come and discuss that in detail. So that's why I didn't even talk about it here. They just introduced the reason why we dropped the column, because there is multicoloniality, but multicoloniality will be explained further. So we'll see details about that in future in dimensionality rejection. Yeah. Thank you for the input. So what Falalu is saying is that there are some issues where we can use what is called fair graph that can show some kind of correlation between features. So we'll see that in the next couple of chapters, which is called dimensionality rejection. So I think chapter, let me see. Don't forget we are following the book Machine Learning with Pytorch and Sklearn. If you don't have the book, get the book. So in chapter 5, yeah, the next chapter discusses compression data via dimensionality reduction. So we'll see this this chapter in the next week. So this is another optional encoding ordinal feature, which is optional. Let's skip it. Let's go to the partitioning a data set into separate training and test set. So we have been seeing this, how we can split our data into training and test set. Now, when you want to do machine learning, this is the kind of data set you can get. This is your full data set, right? This is your full data set. What I mean by full is you can see this is the full data set. Now, the full data set is, it may have a one column, which is the target. So you can separate it. So this is a feature column, this is a target. What we mean by feature column, this is maybe you have student, grade of student. Maybe here is biology, one feature, chemistry, computer science, house, English, geography. And here you have 70, 80, 90, 99, 86. Now the target here, the result will be A. There are some A here. But if you have here 20, 15, 16, 18, 35, then here he has failed, be graduating. But this is first class student. This is withdrawn student. So this is what we call futures and target. Futures is what, when you combine, you can predict the target. Now, when you have this, what we do, we don't actually train machine learning with the whole futures or with the whole target. No, what we do is basically we teach the machine learning and now ask him to evaluate on the something that we have not taught it. So for example, if you are teaching in a primary school or in a secondary, you teach the student how to do addition. 1 + 1, 2 + 2, 3 + 3, 4 + 4, 5 + 5 is 10. Now you train them here, right? So you train them. Now, when you want to see whether they understand that concept, you don't give them 1 + 1 because you teach them. You give them separately. So maybe I can give them 6 + 6, which I don't use to train them, to teach them. I give them 7 + 7 as exam. So I would give them 6 + 6, 7 + 7 to give me answer. This is also how we do machine learning. So in this case, all the features, you divide it. Maybe then cutting it here. Then this one, I will give the machine learning algorithm to do training, to learn. And now this one, I will test it is learning. If it performs well on this one, then we may hope it will perform well here. Because if you are training student, they will say, yes, yes, sir, yes, sir, yes, sir, yes, sir. But when you give them the exam, you just see the all fail. It means they don't learn anything, right? So that's also here we want to try a situation whereby if it good learning, it learn well, then it will learn here as well, good learning. So this is what we call used for training, and this is used for testing. So this is something that we, so let's try to download one data set, and now this data set, we can use it to, yeah, so you can see the data set here. We have the class level. We have some features, alcohol, malic, ash, alkalinity, magnesium, total. So this, if the wine data sets, okay, so this is a wine data set, and I think this wine data set is collected from photo, because photo, they have a good wines. So it's known for wine. So this is the wine that collect for the data set. Just give me a sec, please. Right. So now we have this. You can see this is the class level. So given this kind of stuff, features, alcohol, then the class, it is of class 1. So there are different kind of classes. The classes, I think we have 1, 2, 3. Can you see class level? So now, given this data, how can we divide it into this format, like divide this and this? So thankfully, we have already been seeing this scikit-learn trend split. So scikit-learn provide us with this under the model selection API, provided with this trend test split, right? Trend test split. So one thing, maybe you using machine learning, if you are using VS Code and you want to train machine learning, and all this stuff, they are repetitive. You all do them. You do them every day. Trend test split. You can use what we call snippet here in VS Code. So let me show you here.